Yes, hello, hi, welcome to EDUHUNT IIT and NEET foundation classes. This is Sukumar. See, in previous class, we discussed how to give octet structure or how to draw a structure, Lewis structure, based on the theory or the concept given by Lewis. And we discussed formal charge also, right? What is formal charge and how to calculate formal charge and what's the importance of that formal charge. Now in this video we are going to discuss next concept, that is valency. Valency or simply combining capacity. Combining capacity. See, combining capacity is a very simple and general term. Combining capacity is a very simple and general term, and valency is a technical term for chemistry, right? Valency. But valency means combining capacity. And what is combining capacity and why we need to determine this? Let's see this. See, if you look at calcium chloride, CaCl2, and calcium oxide. Okay, for explanation purpose I have taken two compounds of one common element, calcium. This is calcium chloride and calcium oxide. But if you look at this calcium oxide carefully, here one calcium atom combined with one oxygen. Here one calcium atom combined with one oxygen. It means the combining capacity of calcium is same as combining capacity of oxygen, or you can say the valency of calcium is same as that of oxygen. By looking at this formula, you can say that the combining capacity of calcium is same as the combining capacity of oxygen. That means valency of combining capacity means valency, I said na? Yes. The combining capacity of calcium is same as the combining capacity of oxygen. That means here again I am saying one calcium atom combined with one oxygen. One calcium atom combined with one oxygen. That means one atom combined with one atom. That means they both have same combining capacity. And similarly, look at this, the same calcium atom combined with two chlorines. The same calcium atom combined with two chlorines. That means their combining capacity is different. That means their valency is different. That's why one atom bonded with two chlorine atoms. Right? Yes. Then how to decide this combining capacity, or how to decide this valency, how to determine this valency? We can easily determine this valency or combining capacity with the help of Lewis concept or Lewis symbols. Let me try and let me explain that. See, I hope you know that calcium, this is the symbol for calcium element, and if you know the electronic configuration, let me write the electronic configuration for calcium. Calcium atomic number is 20. That means calcium is going to have 20 electrons. If you write the configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 20 electrons I made. Obviously, first shell, second shell, third shell, fourth shell is the outermost shell. Now calcium, this is the element symbol. Now if you convert this element symbol, if you has to convert this element symbol into Lewis symbol, you have to write the valence electrons also here. Valence electron 1, valence electron, the two valence electrons, the number of electrons present in the valency shell. Now calcium is having two valence electrons. Okay, fine. Calcium. The concept of oxygen electronic configuration, try to write the electronic configuration 1s2, 2s2, 2p4. The first shell, second shell is the outermost shell. Now in the outermost shell, how many electrons? 6 electrons. Now write those 6 electrons. 1, 2, 3, 4, 5, 6, 7. Sorry. 1, 2, 3, 4, 5. So కొంచెం కిందకి రాస్తాం. Yes. Oxygen. Valence, in the valence shell of oxygen, how many electrons? 1, 2, 3, 4, 5, 6. 2 unpaired electrons, 2 lone pairs. Okay, the configuration will be like this: 1s2, 2s2, 2p4. The first shell and second shell. Second shell is the valency shell. In the valency shell, there is 6 electrons. In these 6 electrons. Okay. Now see here. We have to think in terms of only Lewis concept. And what is Lewis concept? Lewis concept says that, or Lewis theory or octet rule says that atom tries to get stability by having 8 electrons in the valency shell. So this calcium atom combining with oxygen atom, because calcium want to get 8 electrons in the valency shell, and oxygen also try to get 8 electrons in the valency shell. Then how can calcium will get 8 electrons in the valency shell? By losing these 2 electrons. That means by releasing these 2 electrons. Okay. And how the oxygen completes its octet? By gaining the 2 electrons. So calcium is getting octet configuration by releasing 2 electrons. So that calcium will become Ca2 plus. Oxygen will complete its octet configuration by gaining that 2 electrons. So oxygen will become 2 minus. That means the valency of calcium is 2 and the valency of oxygen is also 2. That means the combining capacity of calcium is 2 and the combining capacity of oxygen also 2. So let me clear this. Combining capacity is nothing but the number of electrons lost, or the number of electrons gained, or the number of electrons shared to complete a stable configuration, to get a stable configuration. That is valency. So how can we determine valency, or how can we determine combining capacity? Valency or combining capacity is the number of electrons lost, or number of electrons gained, or number of electrons shared to get stable configuration. Stable configuration in according to Lewis is octet or duplet generally. Let me explain with one more example. See, nitrogen. Let us take this compound NH3, right? Now nitrogen Lewis symbol. What is the Lewis symbol for nitrogen? Yes, in the nitrogen valency shell there is 5 electrons. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. Then hydrogen with 1 electron, hydrogen with 1 electron, hydrogen with 1 electron. Now according to Lewis concept, how we determine the covalent bond? Covalent bond means electron pair shared. That means this unpaired electron and this unpaired electron becomes one covalent bond. Next covalent bond. How many covalent bonds? 3 bonds. Now look at the valency shell of nitrogen now. Now the valency shell of nitrogen means this entire thing. That means 1, 2, 3, 4, 5, 6, 7, 8. Now nitrogen has completed its octet by sharing 3 electrons. Right? That's why the valency of nitrogen in ammonia is 3. So how to determine valency? Again I am telling you, the number of electrons lost, or the number of electrons gained, or the number of electrons shared to get stable configuration. Let me write that in the form of definition. The number of electrons lost, or the number of electrons gained, or the number of electrons number of electrons shared to complete or to achieve or to get, and simply to get stable configuration, to get stable configuration. To get stable configuration. To get stable configuration is called valency. So simply, if you want to determine the combining capacity of an atom, or if you want to determine the valency of an atom, you have to look at it, how many electrons the atom has lost, how many electrons the atom has gained, or either loss or gain, doesn't matter. How many electrons the atom is losing, or the how many electrons the atom is gaining, or the how many electrons the atom is sharing to get a stable configuration. But this stable configuration is according to Lewis. So according to Lewis, in general we take as octet configuration or duplet. That means in the outermost shell, if there is 2 electrons, that is also stable like helium. Okay? Yes. Then how to decide, how we can decide this valency for a particular element in a particular group? Let me discuss this. See, we are having groups like, first group like lithium, sodium, potassium, rubidium, cesium. Of course, francium is the radioactive element, I am not writing, no problem. Lithium. Next group is beryllium, magnesium, calcium, strontium, barium. And after that you will find D block. Leave D block. D block, it's a different case. Okay, we will discuss separately. The properties of D block we need to discuss separately. Okay, yes. Boron family, that means boron, aluminium, gallium, indium, thallium. Carbon, silicon, germanium, tin, lead. Nitrogen, next. Nitrogen, phosphorus, arsenic, antimony and bismuth. Oxygen, sulfur, selenium, tellurium, polonium. Fluorine, chlorine, bromine, iodine, astatine. And helium, neon, argon, krypton, xenon and radon. So you all must be in a position to write elements like this. Okay. Now see what is why. See, I hope you know this is the vertical thing. These vertical elements are all together called a group or family, right? This is another group or family. So this carbon, silicon, germanium, tin, this vertical column is called group or family. Why all these elements? While these, but see, let us take, right? Now, lithium, sodium, potassium, rubidium, cesium, all the members belongs to same family. On what basis we have placed these elements in one family? Do you know? On what basis we have placed these elements in one family? Do you know? Because all these elements have same number of electrons in their valency shell. That means all these elements are having same electronic configuration in the outermost shell. That means all these members have same valency shell electrons. That means lithium is 2s1, while in the valency shell only 1 electron. The valency shell only 1 electron. Like that, sodium 3s1. So all the members have only 1 electron in the valency shell. Like that, beryllium 2 electron, magnesium. All these members have 2 electrons in the valency shell, and all the members have 3 electrons in their valency shell. Like that. Are you getting? and all the members have 4 electrons in the valency shell. These are Lewis symbols, right? Like that. I am writing only first one, okay? All the members will have 5 electrons in the valency shell. Next, all the members will have 6 electrons in the valence shell. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. In this family, except that helium, first member, rest of the members all will have 8 electrons in the valency shell. Okay? So that means these are already stable. We discussed it already. Now you tell me, lithium, if you leave lithium, for rest of the members there is a chance. If so, you take sodium. Sodium outermost shell is 3s2 3p. Outermost shell configuration is 3s1. Let me write. Sodium atomic number is 11. You have to write 11 electrons. 1s2, 2s2, 2p6, 3s1. So the valency shell is having 1 electron. Now if sodium lost this 1 electron, then the outermost shell becomes second shell and it is going to have octet. So these like sodium, the rest of the members are also going to get octet or stable configuration by losing 1 electron. By losing 1 electron, sodium is getting octet. Similarly, other members also. So this family is getting stability or stable configuration by losing 1 electron. So the valency is 1. Like that, this family members, by losing 2 electrons, they will get stable configuration, valency 2. Now boron family is very special generally. So leave boron, we will discuss about boron later as an exception of octet. But coming to the case of aluminum configuration is 3s2 3p1. If you lost that 3 electrons, then the configuration will be 2s2 2p6, octet. So these family members can get octet by losing 3 electrons, right? So valency is 3. Carbon is having 4 valence electrons. That means 4 electrons in the valency shell. Okay? Or if the carbon gets 4 electrons, if carbon gets 4 electrons, it will complete its octet. Or if carbon shares this 4 electron, it can complete its octet. That means the total number of electrons carbon has to participate to get octet is 4. That means valency is 4. So if you observe carefully, up to carbon family, valency is equal to number of valence electrons. Valence electrons is 1, valency is 1. Valence electron 2, valency 2, 3, 3, 4, 4. Up to carbon family, the valency or the combining capacity is equal to the number of valence electrons. But after that, nitrogen, in the valency shell of nitrogen, how many electrons are there? 5. But to get octet, nitrogen has to gain 3 electrons. Because already 5 electrons are there. To complete octet, nitrogen has to gain 3 electrons. That means valency is 3, but total valence electrons are 5. That means from this family, number of valence electrons and valency is not same. Then what to do? See, our main target is about a octet. Na? So 8 minus valence electrons. How many valence electrons? 5 valence electrons. 8 minus 5 gives you 3. That is the valency. So from nitrogen family, what you have to do? You have to subtract the number of valence electrons from 8 to get the valency or the combining capacity. Apply to the next family. See, 8 minus how many valence electrons? 6 electrons. So the combining capacity is 2. Why 2? Why 2? By sharing 2 electrons, oxygen can complete its octet. How? See, oxygen, valence electron 1, 2, 3, 4, 5, 6. Now hydrogen came with 1 electron. Now oxygen shared its 1 electron with hydrogen. Then how many? 1, 2, 3, 4, 5, 6, 7, 8. In this molecule, oxygen completed its octet by sharing 2 electrons. That's why valency is 2, you can say. Or simply, oxygen is having 6 electrons. Now, if it gets 2 electrons, it will complete its octet. So these family members can get octet by sharing 2 electrons or by getting 2 electrons. So anyway, valency is 2, that's why. Like that, 8 minus valence electrons 7, combining capacity valency is 1. Now 8 minus valence electrons are also 8, so valency is 0, combining capacity 0. That means according to Lewis or according to octet rule, these inert gas members, the name itself tells us, these members are not having any combining capacity. Their combining capacity or their valency is 0. Okay, N. And in your books or textbooks or any material, you will find another kind of notation. See, normally these groups, this is the first group, second group, the naming of the group will be like this. This is first group, 1A group, like that 2A group, and the boron family is nothing but 3A group, and carbon family 4A, and nitrogen family 5A. This kind of old notation, the group number is given with Roman numbers. This kind of notation also you can find in your books. And 6A, 7A and 8, like that. Okay, but see, same concept from here also, from first group to fourth group. First group to group number 1, valence electrons 1, valency also 1. Group number 2, valency 2, valence electrons 2, valency also 2. Group number 3, valence electrons 3, valency also 3. Group number 4, valence electrons 4 and valency also 4. So up to carbon family, valency is equal to group number. Up to carbon family, valency is equal to group number. Then after carbon family, valency is equal to 8 minus group number. 8 minus group number. Let's do it. 8 minus group number is 5. 8 minus 5, valency is 3. That's it. Valency is 3. Okay? Yes. Coming to the case of, apply to next halogens. 8 minus how many? What is the group number? 8 minus 7. 8 minus group number is 7. 8 minus 7, valency is 1. So 8 minus group number or 8 minus valence electrons, both will give you same answer. Okay. So up to carbon family, valency is equal to total number of valence electrons in the Lewis symbol. And from nitrogen family, valency is equal to 8 minus valence electrons in the Lewis symbol. Let me conclude that and write up to carbon family. Okay na? Up to carbon family, valency is equal to number of valence electrons in Lewis symbol. Okay, I hope you know how to write Lewis symbol. Then from nitrogen family onwards, valency is equal to 8 minus number of electrons in Lewis symbol. One example I will write here. Example, valency of carbon is equal to 4. Why? Carbon is having 4 valence electrons, valency also 4. Example for this, one example, valency for nitrogen, or let me say valency for chlorine, valency of chlorine is equal to valency of chlorine. How to write? 8 minus, then Lewis symbol of chlorine will be chlorine element symbol and valence electrons are 7. 1, 2, 3, 4, 5, 6, 7. Total valence electrons are 7. 8 minus 7, you will get 1, like that. Okay, I hope you understand. Please note it.